Lubrication reduces frictional forces. Whenever something moves, there's usually at least one frictional force acting against it. This causes some energy in the system to be dissipated. For example, air resistance can transfer energy from a falling object's kinetic energy store to the thermal energy store. For objects that are rubbed together, lubricants may be used to reduce the friction between the object surfaces when they move. Lubricants are usually liquids like oil, so that they can flow easily between objects and coat them. Insulation reduces the rate of energy transfer by heating. Have thick walls that are made from a material with low thermal conductivity. The thicker the walls and the lower their thermal conductivity, the slower the rate of energy transfer will be. The building will cool slower. Use thermal insulation. Here are some examples. Some houses have cavity, made up of an inner and outer wall with an air gap in the middle. The air gap reduces the amount of energy transferred by a conduction through the walls. Cavity wall insulation, where the cavity wall is filled with a foam, can also reduce energy transfer by convection in the wall cavity. Loft insulation may reduce convection currents being created in lofts. Double glazed windows work out in the same way as cavity walls. They have an air gap between two sheets of glass to prevent energy transfer by conduction through the windows. Draft excluders around doors and windows to reduce energy transfer by convection. You can investigate the effectiveness of materials as thermal insulators. Boil water in a kettle. Pour some of the water into a sealable container into a safe level. Use a thermometer to measure the initial temperature of the water. Seal the container and leave it for 5 minutes. Measure this time using a stopwatch. Remove the lid and measure the final temperature of the water. Pour away the water and allow the container to cool to room temperature. Repeat the experiment, but wrap this container in a different material once it has been sealed. Make sure you use the same mass of water at the same initial temperature each time. The lower the temperature difference, the better that material is as a thermal insulator. You should find materials like bubble wrap or cotton wool and are good thermal insulators. You could also investigate how the thickness of the materials affect how good of a thermal insulator that it is. You should find that the thicker the insulating layer, the smaller the temperature change of the water, and so the less energy is transferred, meaning thicker layers equal better thermal insulators.